I'd now like to present the Commodore 64 game project video 4. And as always, I appreciate your subscriptions on my YouTube channel and Facebook, joining it, and I'll answer your questions about game design as much as I can, and you can post your comments there. And here's where you can always get the project downloads. They're always available at my GitHub site I created. So what will be learned in video 4? Collisions of sprite against objects, collision detection.asm. More sprites are added to show all animation frames. More ink bin, your sprite.spt are added. Animation is added in player.asm to change sprite animation frames when the player moves around using subroutine animate sprite. We also use the variables sprite char posx and sprite char posy to track which sprite the screen positions. This allows the sprite to walk left, right, up, or down within a range using _cap variables. Before the screen scrolls in that direction, the map is also tracked using variables map x pos, which is horizontal, and map y pos, which is vertical. Subroutines check move right, check move left, check move down, and check move up read screen addresses to check for tile collisions when a sprite bumps against a wall, so on. Player state variables are added to point to new jump tables, change player state, and update player state that call specific subroutines when a player walks left, right, up, or down, managed by 16-bit word values in player state jump table. A new file, collisionroutines.asm, keeps track of all the sprite collisions within the project. As mentioned in the previous video, a 0 returned here, subroutines check move left, check move right, check move down, and check move up means no collision was found, and a 1 means that the sprite collided against a tile object. The screen addresses are tracked at the sprite position and fetch playfield line address using a table lookup to check the color memory data values to see what attribute data is found here, as defined in the map with the charpad tool. The variable collider attr is used to check the screen character data to see the specific characters 8x8 that exist within that area. The subroutine test blocking captures the screen data and masks out the color data to leave only the attributes. Then constants such as col ladder are compared here to see if the sprite touches a specific tile, such as a ladder. In later videos, this will be expanded to add room for newer tiles such as floor and water. And now we're on to the file main.asm. So some of the changes I made in the main loop would actually be this one down here. I always put them in yellow. So the file now we're adding for our binary is collision_detection.asm because we're now going to include collisions in this part of the project. Now for the next state here, we're adding more, since we're going to be using more animation of sprites, we needed to bring in all those, as you saw earlier from the last video where I talked about the character editor, the sprite editor, excuse me, where it shows all the different sprites that exist. These are all those sprites. If you watch the last video, you'll be able to see these frames exactly as I went over them. Now the changes made in player routines.asm. The new changes include animate sprite subroutine that sets our sprite animation frames and timing. And you can see again it's highlighted in yellow there. For move player right, you can see there was changes done here too. This time the sprite will be managed by the variable sprite char posx and maintain on-screen walking positions moving from left to right instead of remaining at a fixed stationary position on the screen. Here we use check move right to check the tiles that occupy the right movement area. And if you pay attention here, which I'll demonstrate more in the code video here, the 100 is tracking the total length of the map from the map position all the way across. And everything else is the deltas and so on. And here's an example of this. When the sprite collides against an object, you can see the right wall here, that area is checked by reading the screen data found there to see the character data that exists. In the subroutine check move right, if a 1 is returned, then a collision occurred. A return of 0 means that the area is cleared for movement. So to reiterate, if he's bumping in this wall, this subroutine right here, when you call it, will actually return a 1, but if he doesn't bump in, it's going to be set to a 0. And here's some more of the right routine. And here's some more of the right routine. I just put these in so you can kind of still see the flow here. We're using the move sprite right to keep track at the top and bottom of sprite, as I showed in the first video. And here's where we're checking that check move right to pass the data in. So B and E, branch not equal, means if it's not equal to 0, the right was done here. Otherwise, it's going to go right into moving the sprite. So it's free to move here. Otherwise, a collision was found. And that's why I said greater than 0 means a collision was found to the right. Now for the move player left, they're very similar. Below we set up the range of the left sprite movement across the screen. And you can see here, and now when he's moving left, I didn't demonstrate this earlier, but in the right routine, there's a player right cap, and here we have a player left cap to see how far can he move across the left of the screen here before we scroll the screen, which is what's going to take place down here. Here we use check move left to check tiles to occupy the left movement area, just like I showed earlier. Bumps into the wall, there's going to be a 1. If otherwise, there's a 0. And that's this one down here for left. And here's the scroll routine for that when he's ready to scroll the screen. And here's the rest of the data. Check move left here. And again, it's checking that value to see if there's a data found here. Otherwise, if it's 0, it's cleared. He can go through. So in other words, if it's a 0, that area is open, so the sprite can keep moving left. And moving down, below we set up the range of the down sprite movement on the screen. And you can see I put a sprite here to demonstrate as he's moving down. This would be that 1 if he hits, or 0 if he's not. And here's our player down cap to see how far down the screen can he go before we scroll the screen. And here's the check down movement. Hopefully you're getting the hang of this one. So if it's equal to 0, that means that area is open so he can scroll, otherwise we're blocked. And down here, same thing. We're just checking the sprite down movement here, and we're ready to move the sprite down, which continues from the one we were at earlier. Okay, now moving player up, similar again. Below we set up the range of the sprite movement on the screen, and we're checking our sprite char POSY, and we're checking the up cap to see how far he can move up before we scroll the screen. Here we use check move up to check tiles that occupy the up movement area. So it's all very similar here. So here I'm showing a ladder above him, for example. So that means that this area exists as a ladder. So what actually happens here, it doesn't block. You can do different things with the game. And this, what I did is whenever he hits the ladder, in the later version, it'll just call the ladder subroutine, which allows him to walk up and down a ladder and essentially not leave the ladder, so he can just walk up and down the ladder. So it kind of behaves a little bit differently than if you were just walking on the ground. And here's the check up movement, doing the same thing as we talked about earlier. And here's the check move up routine. And the sprite's free to move otherwise. And like I said, this will all be explained in the coding video that'll follow afterward. Now for the player states, these are really important because these actually are used to call, and I'll read right here, player states are incremented by 2 as they are indexes to look up the address of the state. Code on the player state jump table, and as an address is 2 bytes, 1 word, the index must increase by 2 bytes. So it's basically the word is going to keep track of the high and the low bytes to see which subroutine are we pointing at. Are we pointing at the player state idle? We're at 0. If otherwise we're pointing at player state walk left, right, which does the right movement. This does the left movement up and down. And that's just calling subroutines to see which state is taking place. And these are the 16-bit values for that get inserted in there. And here we're on to the change player state. So this is the one that's actually calling the motion to set up those values and insert the word values in. And update player state does the actual calls. Once it receives the data, it basically does an indirect jump to it. And here we're now in the player state idle. As you saw, we've been implementing and adding to this already. So I left this one in here because this one's pretty much the same. We haven't changed anything. We're still setting up the idle animation if he's not being moved. It the joystick's just sitting idle. And here's what I did change is in the original one, you saw there was a subroutine where I called basically the player. I don't know if I even called it. I think I just basically added in the player move right subroutines directly inside the code. But here, I'm actually using those codes to call those indirect jumps that are taking place from the 16-bit word values. In this case, it's going to call the walking right movement. Otherwise, it's going to call the left movement. And then we also do the same except for up and down, and that's the vertical check here. And it's going to call the up movement. And then it's going to call the down movement. Now here's the walk right routine. Now the difference in this one, you may have, if you look at the last video and look at this one, is I didn't add in this animation state here because when we're walking right, essentially in the original last video, video 3, we didn't have any animation. So I didn't need to put the animation as he was moving left and right. So I wanted to demonstrate that. So what he's doing here instead is it's now controlling the right subroutine, which is going to basically set the animation. And this call right here initializes the animation. It uses that animation call I showed you earlier that we added to the code. And they're all very similar. And here's moving the player right, because we're still in the move right routine. And the player left routine, again, we made the changes here to the walk left animation because now we want to see the walking left animation. So again, we're going to save those the high and the low and the high bytes into those 0 page pointers so we can call the subroutine that initialized the animation for left. And here you can see we're moving the player left. Now we do this one, this is the player state walk up, and I wrote, the revised changes for this subroutine include creating the walking up animation, which again, is kind of like we were looking at the right and the left animation. Now we're just dealing with the up animation. So it's going to receive those 2 0 page pointers so it can keep track of what are the frames as he's walking up. So these are keeping track of sprite animation frames as he's walking up and down the screen. I mean, this one's, and he's walking up the screen. The other one was like if he's moving left and he's moving right, it's going to keep resorting those different animation frames from those tables. And here it checks the joystick and it moves the player up. And otherwise it's idle, which means he's not moving. So basically it moves his feet up and down. And here's the player state walk down, again, very similar. So this time we're going to be adding in the walking down animation frames, read them into those high and low, those low and those high bytes from the 0 page pointers, and then sending that call to our initialized sprite animation to set the animation. And here we're moving the player down. And these are just some of the variables that are being used by the program for the different states. Now we're on to the sprite routines.asm to see the changes we made here. So since we're now dealing with sprite animation, in the last video we didn't actually need to include these because it was just basically scrolling the screen with the sprite centered on the screen. But now that our sprite's movement, we need to keep track of his movement left. So this is keeping track of the variable data left. And it's also storing this in a bit table, which is allowing it to pass over what's called the most significant byte, as I explained in a previous video, and the least significant byte. So when he's passing past 255, he's able to move, and essentially it's a carry bit is set, so it allows him to move into the next highest position so he can continue across the screen. And that's exactly what this is doing. It's flipping the bits to set the right data so that he can keep moving. And they're all very similar for this one. And this sprite right does the same thing. So as he's moving to the right, it's the same thing. We're keeping track of the sprite position as he's moving, and we're checking that bit table again, and we're going to see when do we need to set that bit as he passes over to the right. And earlier it was to left, so I was going this way, but I meant to go this way. So left is this way and right is this way, of course. So here's where it actually stores the data into the VIC sprite register to see the result. And here's some masking going on to set these bits appropriately. And it also keeps track of the sprite deltas, which go from 0 to 4, I believe it is. And here's the increment of the character position. Because keep in mind, as the sprite's moving on the screen, it's not in line with the character, so we had to do some math to get them to line up appropriately. And here's the move up routine. So as he's moving up, we got the sprite POSY to keep track of the up movement. And here we're doing the same thing again, resetting our deltas as we need them to see how far the sprite has traveled. And we're moving down, move sprite POSY, keep track of the down movement, of course. And again, we're checking those deltas, and so on. Now, as I mentioned earlier, as I showed you the initialize sprite anim, once you get there, it calls anim sprite inside of that subroutine, and this is where the actual animation of our sprite takes place here. So it's keeping track of these animation frames that go on to determine what kind of animation states are taking place, which will be explained more in the coding video, but I just wanted to show it to you here. There's also a timer table going on to keep track of when do we, it basically controls the smooth motion of each animation frame, best way to say it, which is what we're doing right here with the masking. And here's the animation tables that get loaded and saved in so that we can see them on the screen, the sprite frames essentially. This is storing the sprite frames right here. And animation timers, so we're decrementing the timer to see if we've reached the end, and so on. And this reset Pong is where it actually controls those different animation states that are going on. And these are the different states. One of the states is a loop to see if it's going to be a looping animation, otherwise a ping pong, which I believe is like a going back and forth kind of motion, like a ping pong ball. And here's some of the more tables. There's also a counter to keep in track of a specific count that's going on to see if we've reached too many frames to reset. And here we go again, animation. Timers going on here. And so on. There's a lot taking place here. So this is not a complete coding video. This one's just kind of just giving you the code up front to kind of show you it step by step in sequence. And when you look at the coding videos, that's where you really want to pay attention to see what's going on. If you have questions, always feel free to put them on the Facebook and even if in the comments on YouTube if you have to. If you're stuck on something, if something isn't clear to you, let me know. And here we're setting the sprite image. So this is what actually allows you to see the sprite on the screen as the animation frames are going on. And these are the pointer bases for each specific sprite. Remember, we're using right now currently 2 sprites. We're using sprite 0 and sprite 1 for the top part and the bottom part of the sprite. But later, we're going to have more sprites for enemies and stuff like that. And here's some more data. Just used by sprite subroutines. Some of these could be omitted, but they were in here from a previous project. Here's some active to just determine what is an active state of a sprite, which we haven't really gone into here, but it was just left in here for purpose's sake. Here's the sprite deltas, keeping track of those individual deltas, the character positions, delta trimming, and POS extending. And here's some more of the deltas going on with character position and even the sprite direction to see which way is the sprite facing. And here's the timers, keeping track of tables for that, and the counters, play, and then there's a word for the sprite animation to read 16-bit values. Here's the actual loops that are taking place. And there's a play once, and there's that ping pong I talked about. Now, these are going to be used pretty frequently. What these are doing, if you look here, this is actually reading the animation state, and this is setting a specific sequence that goes on within this actual animation state. Whoops, I think I went too fast here. So going back here, this is actually pointing to the appropriate sprite, and then this is setting the animation state for the actual sprite here. And you can see here, this is keeping track of, this actually controls the timing right here, by the way. And this is again timing, and these are the individual sprites. So sprite 18, sprite 20, sprite 22, sprite 4, and sprite 2. So kind of ping-ponging back and forth. You see the ping-pong going on there. And this is a loop because it's actually going in a loop because there's more than just 2. And here's the walk animation. Again, you'll notice there's more than 2. Timer. And here's a walk up. Timer. And there's 2 set for this walking. I only had 2 states for the walking animation, even though I did set that to a loop. I could have probably just used a ping pong for that one. And walking down, same thing. Now we're on to the collision detection.asm. This is what I was talking about earlier, and I was trying to break it down as much as I could. So this is that check move left position. So it's keeping track of our character data sprite, as he's moving to the left here. And it's recording information here. It's keeping track of his deltas to see which tile is he bumping into. It's also keeping track of the scrolling screen as we're moving. A lot of things going on there. And here you can see some masking going on with the sprite data. And down here we got the sprite deltas. If he's going to the left here, we're setting the deltas here. And here's some more of the scrolling. Because he's moving left, it's basically subtracting from it because he's moving backward that way. And this one is really important here. When we get to this address, fetch playfield line address to subroutine, it's actually capturing screen data inside of here that will be used much later in an area that's going to test to see which tile are we bumping up against. And it's this one right here, actually. Test blocking will be working off of this. Notice how this right here, what it does is it keeps track of the 0 page pointer, records them when you're moving down the screen here or moving left and right. It's keeping track of an X and a Y register, or I may have it back, maybe Y and X according to the way the code was set here. But it really, X is left and right and Y being up and down right. So it's keeping track of where is the sprite moving on the screen. And then it's going to say, okay, let's record that specific character position so we know exactly what's going on there. And then we're going to call this subroutine, which you'll see here in a minute, test blocking, to see if we're moving down, left, right, up, and down. In this case, it's left, as we're moving left here. Is there something in the way? Is he blocked? And then it's going to check the left position if it is. And it's going to check, again, the playfield line address, which is used a lot to check the data that's in that area. We always want to keep checking it and test the blocking here to see what's going on with that section. And you notice a lot of these, they're very similar. And here you see it calling it again as it's moving down the screen. Because as we're going to 40, we're moving down the screen there. And so it's going to be keeping track of the next thing going down there from yes. And here's the right subroute. Here's the check move right. So as he's moving to the right, we're keeping track of the character data there. And the scroll positions again. So very similar, repetitive going on here, right? Keeping track of the masking going on here for our deltas. So we stay within the specific range right here, 0 to 7. And right here, this is keeping track of our deltas, of course, and determining our scrolling count Y. So as we're moving right, it's going to scroll that screen, right? And here you'll see very similar things going on, just to get back to the point here. So the fetch playfield line again address, again, is keeping track of those 0 page pointers. And it's going to read those from here by loading them in and checking to see what character data is found. Remember, this is the screen memory, and now it's able to check what's going on with that screen memory, because that will be used a lot in later projects. When he's moving up and down a ladder, for example, it would be checking fetch playfield line address. If he's bumping into a wall, it necessarily may not check for this. It's just when it needs to check data underneath it. Later we'll have where it can check data. But as he's moving left, right, up, and down, it actually is checking everything because it's always needing to check the data that's in that direction. So I kind of said that a little bit backward. But I get how it works. Okay, so load the character data to check move down. Again, we're loading the 0 page pointers and we're checking that data. And we're going to do the same thing for our move down position. We're keeping track of our character's POSX because we're moving down the screen here in our POSXY. So we're keeping track of both of these positions. And then we're keeping track of our deltas. And kind of the same things going on here, except we're checking this in the downward movement. And again, our fetch playfield line address. And when I get to the test blocking, this will make a lot more sense to you, hopefully. That's the goal here. Now we're going to be doing the up movement, so we're checking both of those character positions on the screen. So X and Y, because it's a character position, right? It's got to be positioned at an X and Y position. Checking our deltas. And here our deltas are being loaded, and we're subtracting in the scrolling of the screen there. And again, kind of some repetitiveness going on here. And down here, again, we're checking our play field. Always, anytime you're moving in these collision detections, we're always going to be checking to see what's in that screen data area. So I'm kind of skimming through this because it's very similar. You see it going on right here. And here's our check block under. Now I meant to omit this because I omitted it from the original one, but this will be introduced later to check a block under the sprite, but it's left here for now. But you'll see it again later, so I'm just going to kind of skip through it for now. So now what we have here is the test character for blocking. So these are what I was talking about, those different tile detections that's going on. If it's clear, that means there's nothing in the way. Otherwise, there's a floor there. These are the character data reading directly from the attribute from chartpad. And this is the stair, which is not used in this one, but left here again. This is the rope, which is going to be the ladder. And this is the water, which will be used later in object. And here, this is what's really important. So as we call test blocking here, the first thing we're going to do is we're going to store the data that we found. Remember that screen memory address is going to be stored in collider with attr. So this is the attributes, collider attribute. And then this collider attribute is going to be loaded from the X register so we can get its starting position. And then what we're doing next is we're loading in the attribute mem. This is the data taken from chartpad to determine what did we have in that area. Did we have a block going on or not? And I think I showed that in the previous video. So as you're moving across the attribute, you can store ones, you store twos, threes, determining based on whichever character you're looking for to make a collision on. And here it's always going to store it back so we can compare it. And this is the rope, which is essentially our ladder, and this is the water and so on. And here we're just returning the values off the stack since we threw them on the stack earlier. And here's the data attributes, or the byte values. And that should be the end here. So thank you for watching. And as always, guys, I appreciate you so much for watching this series and being a part of this whole project. And hopefully, if you have questions, go ahead and throw them out. I'd like to try to get people up to speed now, if that's possible, because this next video you're going to see here for the code example is going to show the actual sprite animation moving across the screen, and it's going to look almost like an actual, like you're moving through a maze, essentially. Maybe not even a maze, but you're able to move through a screen environment, and it's going to look more, getting kind of closer to a game now because there's animation going on and there's collision detection occurring here. So yeah, feel free to share this video with your friends, and I just want to thank you guys so much for watching. Hello, everybody. I hope you enjoyed this session of the Commodore 64 game project for Video 4 as much as I enjoyed creating it for you. And in this series, we learned how to go ahead and implement and load in sprite routines so that we could have more animation data to work with for our sprites. And then essentially, we were aligning the character position of the data on the screen and the sprite position so that when a sprite's moving around, it could detect collisions. And the collisions took place in the collisions ASM files whenever we were doing the check move left, check move right, up and down. We would check to see if the sprite has collided into a tile or a screen data that's captured into that data area there by returning a 1. A 1 means a collision was found, so that at that point, the sprite wouldn't be able to move left, right, up, or down. And if a 0 is found, that means that area is cleared, and the sprite can continue moving in that direction. So then more of this will be explained in the coding videos to come, but I hope you guys enjoyed this session. So I appreciate it so much. All your subscriptions mean a lot to me, help me to grow. Dealing with a channel here and a computer that is 30 plus years old, so it's very hard to work out inside of a market that is so massive and so big. There's game designers that just do loop circles around what I've got going on here. So I appreciate helping me grow, passing the word along, because we can keep this alive. I love sharing assembly language tips with you guys. So if you're stuck on something and you're working together with these projects, let me know. I'm there for you, and I'd like to be able to answer your questions as best as I can on Facebook and YouTube. If it's going to be more lengthy, probably leave it on Facebook. So yeah, guys, help me to grow, and I'll keep getting these videos out to you as much as I can. So we have a series of 18 videos here, and there's a coding sample coming here really soon once I have time to put that together for you, of course. And yeah, keep C64 Brain alive, and I appreciate it so much, guys. All your support, everything, all the years, everything you've done, just being there in the teams, and just everything I've learned from you guys has helped me grow so much. Thank you guys so much for watching, and you guys have a wonderful day.